Hello, this is a presentation for class IT 6873 and Southern Polytechnic State University fall 2014, and it's about cross-site request forgery. My name is Asenova-Belal. The overview of this presentation is what is cross-site request forgery, cross-site request forgery vulnerability, which websites are vulnerable, how the cross-site request forgery works. It's called riding the session, example attack scenario, cross-site request forgery mitigation best practices for end users and for applications, misconceptions about cross-site request forgery, defenses that do not work, and cross-site request forgery myths and reality, and how to prevent CSRF or cross-site request forgery. What is cross-site request forgery? It is also called the sleeping giant. It is an attack that forces a logged-on victim's browser to send a forced HTTP request, including the victim's sessions, cookie, and any other automatically included authentication information to vulnerable web application. This allows the attacker to force the victim's browser to generate requests. The vulnerable application thinks that are legitimate requests from the victim. Down here you can see a snapshot about how this works. Here we continue about the cross-site request forgery. Also is known as CSRF because of the abbreviation, or XSRF. This is a type of malicious exploit of a website whereby unauthorized commands are transmitted from a user that the website trusts. Cross-site request forgery vulnerability. The seed for the vulnerability goes back 25 years ago to the birth of Internet and World Wide Web. The bad people have all the time in the world and they need to be successful only once. When us, the enforcement team, have to be successful 100% of the time. Security vulnerability is a symptom. The root cause is always something else. Cross-site request forgery vulnerability exploit the trust that web applications have to the client browser. It exploits a user privileges and trust to a particular website. It exploits the trust that application have on authenticated session, and it is a client-side browser attack. Identifying the attacker is very difficult because it occurs in the context of the authenticated user. The key characteristic of cross-site request forgery vulnerability are that the application accepts a request that makes something occur on the server, and the attacker can determine all the parameters of that request to another user. The cross-site request forgery should not be confused with cross-site scripting, because cross-site scripting, or XSS, the attacker exploits the trust a user has for a website. When on the other hand, for cross-site request forgery, the attacker exploits the trust a website has against a user's browser. And cross-site request forgery involves two key components to be successful: a willing victim, which cannot be controlled, and vulnerable website, which can be controlled, and we can do that. To check the vulnerability, whether an application has or not, we can do that by seeing if any links and forms lack of unpredictable cross-site request forgery tokens. Without such token, attackers can forge malicious requests. An alternate defense is to require the user to prove they intended to submit the request, either through re-authentication or some other proof like CAPTCHA. Also important is focusing on the links and forms that invoke state-changing functions, since those are the most important cross-site request forgery targets. The multi-step transactions should be also checked as they are not inherently immune. Attackers can easily forge a series of requests by using multiple tags or possibly JavaScript. Session cookies, source IP addresses, and other information automatically sent by the browsers don't provide any defense against cross-site request forgery, since this information is also included in forged requests. Which websites are vulnerable, we may ask? Any website that has not taken specific steps to mitigate the risk of cross-site request forgery are vulnerable. Every piece of sensitive website functionality is also vulnerable. According to the Open Web Application Security Project, or OWASP, cross-site request forgery is not a new attack, but is simple and devastating. This vulnerability is extremely widespread. All web application frameworks are vulnerable to cross-site request forgery. How CSRF works, or also called riding the session. HTTP is a stateless protocol. Web applications maintains state throughout session ID in cookies or URL parameters or hidden variables. The server trusts the session ID coming from the browser. For authenticated session, the browser does not resend a new session ID to the application as a proof that each HTTP request is authenticated. This allows for riding the session with an interleaved malicious HTTP request. If an attacker phishes a victim forcing him to select a web page that has a malicious HTML tag such as iframe with an embedded GET request, and if such request is issued when an authenticated session with the same application is still valid, then such malicious request will be processed by the application and the user is toast. The web application server implicitly assumes that any request that comes in expresses the will of the user as it comes from the user browser. The application does not take into account that the request may as well have been foisted on the user by a third party. Is this a web application's fault? For example, like when we go to the airport, is this TSA fault? Though most users have good intentions, the server-side application has the responsibility to check for the 1 in a million bad users and their requests. The attacker abuses an existing session in the victim's browser. He or she writes on it. This is known as a session riding or as known as cross-site request forgery. Implicit assumptions are bad for security. Example attack scenario. Let's say the application allows a user to submit a state-changing request that does not include anything secret. For example, the user go to example.com and want to transfer the money from his account to his friend's account. So the attacker constructs a request that will transfer money from the victim's account to attacker's account and then embeds these attacks in an image request or iframe stored on various sites under the attacker's control. In our case is image request. So if the victim visits any of the attacker's sites while already authenticated to example.com, this forged request will automatically include the user session into info authorizing the attacker's request, and therefore the user will find that his money from his account are gone and they are not in his friend's account. Cross-site request forgery mitigation best practices. This is for the end user. Log off immediately after using a critical web application. Do not save username password. We tend to do that now because of so many passwords we are using, because of so many password policies we have and different requirements. So sometimes we say, remember me on your login, or you save my username and password. That is not good. Do not use the same browser to access sensitive applications and to surf freely the internet. However, if both things have to be done at the same machine, do them with separate browsers. For example, Firefox and Internet Explorer, or Internet Explorer and Google Chrome, or Google Chrome and Firefox. You have to have all these browsers in your machine and use them for different applications. Sometimes this can cause speed issue and also crashing, but it's a it's a way to prevent the cross-site request forgery. Using HTML embedded mail poses additional risks since simply viewing a mail message may lead to the exclusion of an attack. So be careful with the mail you receive and report it as spam, anything don't sound familiar to you. Check computer for malwares frequently. And remember, application has no control over end user behavior. In this case, us. Cross-site request forgery mitigation best practices for applications. Insert custom random token into every form and URL. Make sure there is an XSS HTML tag injection, link injection, phishing vulnerabilities in user application. Re-authenticate when performing high-risk transactions, like sending money. Do not use GET requests for sensitive data or to perform high-risk transactions. Do not allow post variables as GET when submitting forms. When using Flash, always have restricted cross-domain.xml file on the server. When redirecting out of domain requests, implement a whitelist approach. Disable all unsafe HTTP methods, all except GET and POST. Misconceptions about cross-site request forgery. Defenses that don't work. One of them is only accept posts. It stops simple links-based attack, images, frames, etc. But hidden post requests can be created with iframe script, etc. So that does not work. Refer checking. Some users prohibit refers, so users can't just require referrer headers. Techniques to selectively create HTTP requests without reverse exits. requiring multi-step transactions. Cross-site request forgery attack can perform each step in order. And another that does not work is URL rewriting. What are the myths and reality about cross-site request forgery? One of the myths is that cross-site request forgery is a special case of cross-site scripting or XSS. The reality is that different vulnerabilities, root causes, and countermeasures and XSS can facilitate cross-site request forgery. Another myth is that posts are not vulnerable to cross-site request forgery. It is more difficult to exploit, but they can lead to automatic submission. And the third, but probably not the last one, just because of the limited time of this presentation, we'll stop here, is that the cross-site request forgery is low-risk vulnerability. Can perform any unauthorized business transactions such as change password, force logouts, transfer money, disclose information, and even false login. How to prevent cross-site request forgery? Preventing cross-site request forgery usually requires the inclusion of an unpredictable token in each HTTP request. Such token must be unique per user session. The preferred option is to include this unique token in a hidden field. This causes the value to be sent in the body of the HTTP request, avoiding its inclusion in the URL, which more prone to exposure. The unique token can also be included in URL itself or a URL parameter. However, such placement runs a greater risk that the URL will be exposed to the attacker and this compromise the secret token, the unique token. OWASP cross-site requests for the regard can automatically include such tokens in Java EE. On the end of the presentation, I have links to this. In .NET or PHP apps, OWASP ESAPI includes methods developers can use to prevent cross-site request forgery vulnerabilities. Requiring the user to re-authenticate or prove they are the user itself can also protect against cross-site request forgery. Here are a list of references I have been using for preparing this presentation. The reading list I propose to you to read in your spare time. There is really very interesting articles and websites, and you can read to learn more about cross-site request forgery. And the last slide is about singularity. This is something I heard about now while I was preparing my presentation. And these two videos really changed my perspective about things. In one of them, the scientist Ray Kurzweil said that by the year of 2045, human intelligence will enhance a billion-fold thanks to high-tech brain. Excuse me. Extension, he refers to this phenomena as the significantly a point at which human and computers will merge. This sort of one in two will create serious challenges for security in the allocation of moral accountability between the two significantly. So please enjoy watching these videos. The second one is about how the future will look like. They are very interesting and change my perspective. Enjoy and thank you for your time.